Mathematics made easy, no more fear. Target online class, we got you. Wherever you want to from, we got what you need. Target online class.
Good day, viewers all over the world. You are welcome to Target online class. Today we want to do a question and answer on elementary mathematics. And of course, elementary mathematics, if the questions were to be CBT, that is multiple choice question, most of these concepts must be well understood. I'm going to start with the set of numbers. Set of numbers. We must understand it very well. Set of numbers. We must understand this very well. Know the meaning and the types and the set of numbers that we have. And that is what I will start with today. So the first set of numbers are called the natural numbers. The first set of numbers are called the natural numbers and is denoted as n, or in some books you see something like this. So what are natural numbers? Natural numbers are the positive whole numbers. And this is the set of this number. When you have 1, 2, 3, up to infinity, up to 1 million, 2 million, 3 million. They are the positive whole numbers. So the second set of numbers, this concept is very important. You must know all this very well. Then the second one are called the integers. This is the notation for integers. Or in some textbook, you might have something like this. In some textbook, they may use I. So what are integers? Integers comprises the negative whole numbers, say -2, -1, 0, 1, 2, up to infinity. That is when you talk about integers. It includes the negative whole numbers, the positive, and 0. So you realize that natural number starts from here, from integers. It starts from 1. So natural number is a subset of integers. Okay? Natural numbers, integers are bigger than natural numbers. Then the third set of numbers are called the rational numbers. That is R, rational numbers, denoted as R. These are numbers that can be expressed as A over B. Please note all this. So that is numbers that you can express as fraction are called rational numbers. Numbers you can express as fraction are called rational numbers. An example is the set of this can be from minus infinity. You can have like 3 all over 2, minus 3 over 2. You can have minus half. Of course, these are part of the number. You can have something like 5 all over 2. It could be negative or positive. In the set of rational numbers, is the extension of integers that involves improper fraction. That is fraction that the numerator is greater than the denominator, and it could be positive or negative. Then invariably, we realize that the natural numbers are subset of integers. Integers are subset of rational numbers. That is, this one, the natural number is inside integers. Integers, they are inside rational numbers. And in that order, please note, and the set of rational number, this b must not be equal to 0. That is, b must not be equal to 0. Once b is equal to 0, this fraction will be undefined. The fraction will be undefined. Just know that b cannot be equal to 0. Then we have the fourth set of numbers. These are called the irrational number. They are called the irrational number. We denote it as IQ. No, this is Q. Rational number is denoted as Q, not R. It's real number that we denote as Q. So IQ. So under the rational number, these are numbers which cannot be expressed as a fraction and has a decimal form consisting of infinite string of numbers that do not display a repeating pattern. So in this case now, when you have numbers in form of pi, square root of 2, irrational numbers, square root of 3, exponential, etc. These are examples of irrational numbers. The example of irrational numbers, we should note. Then the largest set under the real sense are called the real numbers. This is real number. Then any number you can think of. Real number is like the mother set, like universal set. Under the real sense, under the real numbers. So this simply means It is the union between the rational, union, irrational. You know, union simply means either you have the number in rational or irrational. So any number you can think of in the real sense actually falls under this real number. You can check my video on that set of numbers. Please check my video on that set of numbers. Look at it very well diligently and know what you are what is expected to know. Then the last set of numbers are called the complex numbers. So in the case of complex number, these are the numbers that we can express as a plus ib. From number 1 to 5, they are just real numbers. But this sixth one, this set of numbers it's called the complex number. These numbers are unique. It has two parts. It has the real part and it has the imaginary part. So there are some complex problems that we can't get the solution in the real sense. We have to formulate the problem to the rational to the complex sense, and that is where we use all this complex number. So you must note that this I simply tell us that this B here is the imaginary part of this complex number. A is the real part. Okay. Then you should also note, you have to note that I is equal to square root of -1. So that I squared is equal to -1. And this is how we solve problem under complex number. For instance, if you have to simplify, let's say you are given, you have to find the value of -4. If you press your calculator from today till tomorrow, it's going to give you error because you cannot find the square root of -4 in the real sense. It's not possible. The only thing you can do is that you can split it into two. Say this is -1 times 4, which is still the same thing as -4. You now split it as square root of -1 times square root of 4. This is the solution. This is how to go about the solution. What is square root of -1? It is I. This is I. Multiplied by square root of 4 is 2. At the end of the day, your answer will be 2i. So this type of problem does not have real solution. You can only get solution to them in the complex sense. So this is the first topic that we discuss in elementary maths 1. So you check my videos. Just go through my videos. So I'll quickly go over indices, which is the second topic. I'll go over indices. So indices. In case of indices, I only give. Please, you go through my videos. You have a lot of examples there. Indices, but I just want you to understand the concept. When you have a number x raised by a times x raised to power b. No, when you have a number, say x raised to power a, this x is called the base, and a is called the exponent. You can call it exponent, or power, or you call it index. That's what you do. And there are some laws that guide indices. You can check my video on indices and simple exponential equations. I got about 150 something videos on YouTube. Just go through the ones that you know. The ones that it is expected that you should know. Then the first one is that there are some laws that guide indices. S raised to power a times s raised to power b will be s raised to power a plus b. So when it is minus, when it is division raised to power b, it will be s raised to power a minus b. Then note that the c, when we have s raised to power minus a, that is, if the power attracts a negative sign, it will be reciprocal, 1 over s raised to power a. Then if you have s raised to power 0, that's going to give us 1. Let's just take one example, e.g. on this, if you have 2 raised to power 4 times 2 raised to power 8, you don't need to express this. Just say this is the same thing as 2 raised to power 4 plus 8. Then this will be 2 raised to power 12. That is what you get. That's what you are going to get. Then in this case now, under this, with the division, e.g., if you have 10 raised to power 5 divided by 10 raised to power 2, this will just give us 10 raised to power 5 minus 2. When it's division, you subtract the power. When it's multiplication, you add. And this will give us 10 raised to power 3. Okay? Then here, e.g., if you have 2 raised to power minus 3, this same thing as 1 over 2 raised to power 3, and it's going to be 1 over 8. Then the last one, let's say you have 150 raised to power 0. What is the answer? 1. The answer is 1. So that is that about indices. So you check my videos on indices and simple exponential equations to look for further examples. But at least you should know This, you should know all this. Know all this. Because when you have multiple choice question, you should be able to work with all this. So you must understand most of these concepts very well. Then we talk about logarithm. Logarithm. So in case of logarithm, there are some laws that also guide logarithm. For instance, when you have log A plus log B, it says that this is log A, B. You can be asked. Then if you have log A minus log B, it's same thing as log A divided by B. That's what we do. Then number 3, if you have log A raised by n, it's same thing as n log A. Okay. If the 4th one, if you have log A base A is equal to 1, then the 5th law says that if you have log A 1 is equal to 0. So please, you note all these laws, because the application of this law is what we are going to actually apply to be able to know what we are doing. So you can check my videos on logarithm. You can check my videos on logarithm, and of course you can ask questions on this. You can ask question in form of the question I said, evaluate or simplify log 8 plus log, say, 4. Now note, if you are given a logarithm without base, you assume the base to be 10. That is the standard. So in this case now, we are going to have log 8 times 4. Okay? That's what we are going to have. Or we are going to have log 8 times 4. And at the end of the day, we are going to have log 32 as an answer. We are going to have log 32. So if you are given a base, if you are given a logarithm without base, you assume the base to be base 10. Then there's this other one, natural logarithm that we have. When you have log ex, you can be asked that how do we rewrite this? This same thing as in x, because the base here is e, is a natural logarithm. This natural logarithm. So is that you call it this or this? And this is actually important for people that for some people that are going to that will still do differential equations. So under differential equations, those concepts are very important. Derivative of exponential functions. So you check my videos on logarithm. Then we also talk about surds. Surds, irrational numbers. We actually we have the concept surd because of irrational numbers. Then if you have surds, you should be able to. There are some laws that guide surd. For instance, when you have square root of a times b, the same thing as square root of a times square root of b, we can split it. Then 2, if you have square root of a all over b, the same thing as square root of a all over square root of b is possible. But if you have square root of a plus or minus b, you can't split this. You can't say this is a square root of a plus minus square root of b. This is not possible. It only works for this multiplication and division. Then we have the concept surd as a result of irrational numbers. Then for us to be able to simplify any problem under surd, we must write that number as the surd in its basic form. For instance, if you have square root of 18, the basic form of this simply means that you split this number into 2, in which one will be perfect square and the other one could be any number. For instance, I can split this to 9 times 2. 9 is a perfect square. Why is it a perfect square? Because the square and the square root of 9 is going to give us a whole number. Square root of 9 is 3. Square of 9 is 81. So 9 is a perfect square. A perfect square is when you say a number is a perfect square, it simply means that that number, the square of that number and the square root of that number is going to give us a whole number. 2 is not a perfect square because the square of 2 is 4. The square root of 2 is 1.1414. So it's not a perfect square. So if you have a surd, for you to be able to perform any operations on that surd, you try as much as possible to rewrite that surd in its basic form. And the basic form of 18 simply is the same thing as 3 square root of 2. Because square root of 9 is 3. Then 3 multiplied by root 2 is going to give us this. So it is very important for us to be able to solve any problem on that surd. You must write that number in its basic form. Let's get that right. In its basic form. So once we are able to write the number in its basic form, then we can actually perform so many operations on that that set of surds. For instance, you can say addition, division, addition, subtraction, and multiplication. Then also note that if you have a surd, 3 minus root 2, there's what we call the conjugate of a surd. Conjugate of a surd simply means that you change this sign. For instance, 3 minus root 2 The conjugate of this sort is 3 plus root 2. So just change. If it is minus, you change it to plus. If it is plus, if you are given that, what is the conjugate of square root of 3 minus square root of 5? So in the option, you know, you are going to have so many options, A, B, C, D. Then the conjugate of this will just be square root of 3 plus square root of 5. So why do we need the knowledge of conjugate? The knowledge of conjugate is actually required when we want to do rationalization. Rationalization simply means that when we have sorts that involve fraction, then we use the concept of conjugate to be able to rationalize the sort. For instance, if you have 1 over square root of 5 plus 3, if you have to simplify this, how do you simplify this? We are going to multiply both the numerator and the denominator by the conjugate of this denominator. That is to say, this is the same thing as square root of 5 minus 3 all over square root of 5 minus 3. But without the knowledge of conjugate, you will not know what to do here. This is rationalization. Please, you check my video on sorts. Check my video on sorts. I've asked you to check about 4 videos now. Indices, logarithm, set of numbers. Then you also check my video on sorts. Then if you do that, we are going to have square root of 5 minus 3. So at the denominator, we are going to have 5. We are going to have 5. So that's what we are going to have. Or let's say there's 2. You have 2 here. We are going to have 5. Then 5 minus 3. At the end of the day, the final answer will be square root of 5 minus 3 all over 2. That's what you are going to get. So please note the meaning of conjugate. And when we apply conjugate, we apply it for rationalization in order to be able to rationalize a sort. So these concepts are actually important and they are necessary. These are some of the things that you should know. Then we also introduce polynomials. I have videos on polynomials, so you can check. I think I have about two videos on polynomial. Let me just go through the important thing there. Under polynomial, if you have polynomial P of x to be equal to 2x plus 3, and you have another polynomial Q of x to be equal to 3x squared minus 5, you can be asked to add this polynomial. You can perform so many operations: divide, subtract, multiply. Then what do you do? Under addition and subtraction, say P plus Q. That is, I just decided to call this P and I decided to call this one Q. What do? You just add the two together. You add polynomial based on their degree. Constant to constants of degree 1, the one that has raised power 1 to raised power 1, degree 2, raised power 2 to raised power 2, degree 3, the same thing. But in this case now, the final answer will just be 3x squared plus 2x minus 2, because this one only has 3x squared. It has 2s. We don't have anything coefficient of x here. But the basic idea under addition and subtraction of polynomial is that you look at the degree. If you have 2s raised power 10, the other one also has 2s raised to power 10. You add it together. If it doesn't have raised power 10 in the other one, you leave it like that. You only add or subtract polynomial with the same degree. The same degree, like 2s squared, 3s squared. You add them together. So that's just the idea. Under multiplication, it's going to increase. That is when you have PQ, P multiplied by Q. Of course, the degree will increase by the highest power. If the highest power here is 1, the highest power here is 2, then 1 plus 2, that will be 3. It's going to increase. If I expand this now, I'm going to have, when I want to expand this 2, I'm going to have 2s plus 3 multiplying 3s squared minus 5. Then what I'm going to have is that this will multiply the 2. This will also is a form of expansion. Then I'm going to have 6s cubed minus 10x. Then I'm going to have plus 9s squared minus 15. So at the end of the day, the final answer will be 6s cubed plus 9s squared minus 10x minus 15. You realize that under addition, the highest degree is just the highest degree in the question. But under multiplication, the highest degree is where you add the power together, the highest powers together. This is 1, 2, that's 3. We have seen the multiplication. Then if it is division, it has a law. If it is division of polynomial, then you put the one with higher degrees inside 3s squared minus 5. You want to use 2x plus 3 to divide this. So you check for what you can use. This is x. Of course, there will be x here. Then how do you get 3 here? How do we get 3 here? Automatically, this will be 3 over 2. 3 over 2x. That's what I'm going to use to multiply. 3 over 2x times this is going to give me 3s squared. Then plus 9 all over 2x. That's what I'm going to get here. I will introduce negative. So here we change to negative. This will cancel out. At the end of the day, I will have 9 all over 2x minus 5. Then here, this will give me plus 9 here. So how do I get this value? I'm going to get plus 9. No, I'm going to get, for me to be able to get this, I'm going to get, of course, 2 will be here. Then I will get 9 all over 2. This 9 over 2 here. So what do I do to get, here is minus 9 over 2. So I'm going to have minus here. Here will be minus. So what will I use to multiply 2x to get minus 9 all over 2? So that's what we check for under the long division. Then if I do that, I'm going to get 9 all over 4. So if I have 9 over 4 there, if I use this to multiply this, I'm going to have minus 9 all over 2x, then minus, that I say 27 all over 4. If I introduce minus here, it will be plus. This will cancel out. And at the end of the day, the final answer will be 27 over 4 minus 5. That will be 4. 27 minus 20. The remainder will be 7 all over 4. And that will be the remainder in that given question. That will be the remainder. So under this polynomial, we realize that our polynomial is equal to the polynomial. Under this now, there's a way we rewrite that polynomial. The polynomial will be divisor multiplied by quotient. It will be divisor multiplied by quotient plus remainder. This formula is very important. Please note the formula is very important under division of polynomial, because we can actually use what is called the remainder theorem if you don't want to use this. So that's what you are going to get. So if you have any, if you are given any polynomial, how do you get your polynomial? It will be the divisor times quotient plus remainder. Quotient is the result. Okay. For me to be able to get my polynomial back, I'll use divisor. In that question now, the divisor is the one with degree 2. The quotient is what we use to divide it. Then the result is what we got as 7 over 4. If we put everything there, we are going to get an answer. So that is that about division of polynomial. You can check my videos. And there's what we call the remainder theorem. The remainder theorem is just telling us that if you have a polynomial, say f of x, if you have a polynomial f of x, and you have a value x minus a, which is the coefficient, we use this to divide the polynomial. The remainder is telling us that the remainder at the end of the day will just be f of a. It will be f of a. That is, if you want to use anything to divide, just say x minus a equal to 0, s equal to a. By the time you substitute the value of s equal to a, the value that you are going to get will be the remainder to that problem. That is what the remainder theorem is just telling us. So please, you check my videos on polynomial 1 and 2. I have videos on it, on polynomial 1 and 2, just to be able to know remainder theorem and factor theorem. So these concepts are very important. They are very important. Then I will quickly introduce a theory of quadratic equation. Quadratic equation, the general form of quadratic equation is ax squared plus bx plus c equal to 0. So this is the general form of quadratic equation. And of course, we can solve this equation using 4 different methods. This quadratic equations. We can solve the equation using 4 different methods. We can use what is called the factorization method. The factorization method, that's the first method that we can use. We can use the factorization method. You can be asked that the following are methods that we can use in solving quadratic equation, except we can use the factorization method. We can use the formula method, where we will be given the formula. We can use the completing the square method, completing the square method. Then we can actually use the graphical method. But there is limitation to this fourth method, graphical method. For us to be able to solve this quadratic equation using graphical method, we must use the graph. So if graph is not available, then we can't do that, because the use of graph is required to be able to solve quadratic equation using graphical method. The factorization method also has its own limitation. Not all quadratic equations are factorizable. There are some that you won't be able to factorize. The important method that can solve any given quadratic equation problem is the completely square method and the formula method. Then if this is a given quadratic equation, the general formula that we use when you know this is the general form of quadratic equation is x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. This is the general method that we use, and this is the formula that we use to solve any given quadratic equations. Quadratic equation of degree 2. When you say quadratic equation, the highest degree will be 2. If the highest degree is more than 2, it's not quadratic equation. So example of quadratic equation is when you have x squared minus 3 equal to 0. This is a quadratic equation. Though. That question is a quadratic equation. It only shows that in that question, the coefficient of x is 0. The coefficient of x is 0. So that is just the implication. That's the implication there. It's a quadratic equation, but it shows that the coefficient of x is 0 because you know we don't have anything in form of x here because the coefficient of x is 0. So it is also a quadratic equation. Once you know the idea, if you have the highest degree of the equation to be 2, that equation is a quadratic equation. And those are the methods that we use. Then if you solve this problem, we are going to get two values for x. S is equal to this or this. Whenever we solve quadratic equation, because the degree, the highest power of the highest degree is 2, we are going to get two values for the unknown. If the unknown is x, there will be two values for x. If it is y, there will be two values for y. So please let's note. Then let's say we solve a particular quadratic equation, we got a value to be s equal to 2 or minus 3. So these are called the root of the equation. What if you are given the root of the equation? Can you can you derive that quadratic equation? That is the question. You know, when we solve a quadratic equation, let's say s squared minus 5s plus 6 equal to 0. This is just an example. So if you solve this and you get this as the root of the equation, if you are given this, can you get this back? Is it possible? Yes, it is possible. Then you can check my video on theory of quadratic equations. If you want to get this back now, there's a standard formula. It says that s squared minus the sum, let's say it's alpha plus beta, then plus product alpha beta equal to 0. That is, we say s squared minus, what is the sum? When you add these two together, what is the sum? The sum is minus 1 into bracket x, plus the product is minus 6 equal to 0. At the end of the day, the answer will be s squared plus x minus 6 equal to 0. That is the question. So that simply means that the given quadratic equation here is s squared plus x minus 6 equal to 0. This is the question. This is the quadratic equation. When you solve this, you get this. What if you are given this? You should be able to get this. And that is what we are trying to say here. That is vice versa. So that's what you do. Then there's what we call the symmetric property under quadratic equation. That is, if you are given any quadratic equation, like what we have there, s squared plus x minus 6 equal to 0. So we might be asked to find the sum of the root. Sum of the root of this quadratic equation to be minus b all over a by formula. We can be asked to find the product alpha b is going to be c all over a. So please note all this. We have to note all this because if you want to do the symmetric property, for instance, you can be asked to find s squared plus b, alpha squared plus beta squared. So this will be alpha plus beta all squared minus 2 alpha beta. So please, you check my videos on theory of quadratic equation. You can be asked to find alpha minus beta, which is not sum and it's not product. This by formula will be alpha plus beta all squared minus 4 alpha beta. So you can be asked to find so many things under symmetric property. Alpha cube plus beta cube. You can be asked to find so many things under that. Then we also talk about the nature of quadratic equation. That is, we use discriminants to determine the nature of quadratic equation. So please, you go through my videos under theory of quadratic equation. And of course, we know the meaning of simultaneous equation. We know simultaneous equation. In simultaneous equation, we have two equations. We have two equations under simultaneous equation, but both equations are linear. Linear in the sense that under quadratic equation, I said the general form is as squared plus bx plus c equal to 0. But if you talk about simultaneous equation, you can have something like 2x minus 3y is equal to 4. You can have x plus y equal to 8. This is equation 1, this is equation 2. This is example of simultaneous equation. We have two equations with two variables, x and y, but both variable has degree 1. It's raised to power 1, raised to power 1. So this is example of simultaneous equation. Then, of course, under simultaneous equation, we can use three methods also to solve simultaneous equation. We can use elimination method, we can use substitution method, then we can also use graphical method to solve this. Then if you take this to a bit, if you take this to a bit advanced level, we can use what is called Cramer's rule under matrices. You can check my video on matrices to solve simultaneous equation. And if you solve the simultaneous equation, we are going to get the value of a. We get the value for x and y once we solve that simultaneous equation. So that is that about that. Then I will quickly talk about sequence and series. I also have a video on this. You go and check. We have so many examples there. Sequence and series. What is sequence? Sequence is arrangement of number in a sequential order. For instance, when you have 1, 3, 5, 7, 9, and so on. This arrangement has a particular pattern. The common difference there is 2. So we arrange this number in a particular pattern. So it is called sequence. We can have something like 1, 2, 4, 8, 16. Look at this also. It's in a particular pattern. The difference here is 1, 2. Here is 4. Here is 8. There's progression. So it's a sequence. If you look at this first one is called a linear sequence because it has a common difference. It's called a linear sequence. Linear sequence is otherwise known as AP, arithmetic progression. If you look at this second example is called an exponential sequence because it has a common ratio. There's progression. How do you get the common difference? D. The common difference, D simply means the second term minus the first term, or third minus second. This will be 3 minus 1, and that is 2, which is common there. Then that is under linear sequence, AP. Under exponential sequence, which is GP, geometric progression, we have what's called the common ratio. The common ratio simply means the second term divided by the first term, or the third divided by the second. And here we also get 2 as the common ratio. Okay, if I say 16 divided by 8, it is 2. 4 divided by 8, it is 2. So this is under common the exponential sequence, we have common ratio, R. Under linear sequence, AP, we have common difference. Then the formula to find the nth term, the last term, or nth term of an arithmetic progression is given as a plus n minus 1 into bracket d. Okay, that's the formula to find the last term or nth term of an arithmetic progression. Then the formula to find the last term or nth term of a geometric progression is given as a raised by a into bracket r raised by n minus 1. This is the formula that we use to find the nth term of geometric progression. So please let's take note of all this. Then that is that about sequence. Then what do we call series? Series is just the addition of all the terms that we have in a sequence. For instance, 1 plus 3 plus 5 plus 7 plus 9. So this is series plus ... Series simply means when you add all the terms in a sequence together. 1 plus 2 plus 4 plus 8 plus 16 plus ... For the AP that we do the other time, linear sequence, when you now add all the terms together, it is called series. That is series. Series is the addition of all the terms that we have in a sequence. For AP, which is linear sequence, the sum by formula is n all over 2 into bracket 2a plus n minus 1 into bracket d. Of course, if you check my video, we are able to generate this. Or if you know the first term, and the last term, just say this is same thing as a plus l. That's what you get. So this is the formula to find the sum of AP. That is series. That's the meaning of series. Then for GP, there are 3 things that is involved, depending on the value of R. So if R is greater than 1, there's a particular formula that we use. If R is greater than 1, we use a particular formula. If R is less than 1, if R is greater than 1, then we are going to have the sum will be A into bracket Rn minus 1 all over R minus 1. So if the common ratio is greater than 1, if R is greater than 1, we use this formula. So if R is less than 1, the sum will be A into bracket 1 minus R raised by n all over 1 minus R. That's another format. Then the third one that we know is when r tends to infinity, then the sum to infinity will be a all over 1 minus r, and that is what we are going to get. So please, you can check my videos on series and sequence. I would love to stop here because of our time. By the grace of God, we are going to continue from there. At least we have been able to revise about 7 or 8 topics. So you go through this, then we come back later. We continue from there. Thank you, and God bless you all.